All right. Today is March 19th, 2025, and we're going to have our March meeting. So, good morning, everyone. The warmer weather is definitely slipping in here, which is awesome. And along with that comes air conditioning. And we at Shenandoah, we have a board with all of our buses that need air conditioning work done on them, or at least checked. So we check all of our buses every spring, and then we check them off. So as they come in for a PM, we'll check them off the board. And what we do is we hook them up. We don't always hook them up to the machine, but we make sure that the air temperature is putting out properly. The compressor is not cycling fast. If we have to top it off with a little bit of refrigerant, we will. But that also could mean that there's a leak. So we look for the green, we look for all that stuff, and order a condenser or a compressor as needed. Those seem to be the items that we change mostly. But we'll let Chris present on air conditioning here when we get going. So our last meeting was held on February 12th, 2025. Jeremy Johnson with New York Bus Sales presented on the Bluebird electric bus and the changes and updates since last year. And some of the things that he spoke about. And the meeting was recorded and it is on our channel. So if you want to watch that again, you can to get the information. But he was talking about eco tuning. He said that they just put $80 million that was awarded to Bluebird. $75 million was awarded to Cummins for battery production. So that is changing. They have Type A 24 passenger buses in production, fully electric. Microbird is building a plant in Plattsburgh, $38 million worth. The batteries went from 88 kilowatt hours to 175 and 140, and this is getting them the 200-mile range. They have done away with their two-speed transmission. I think they were the only ones that had a two-speed transmission, and they are no longer doing that. They have remote bus preheating right from your PC, so you can kind of like in charge and stuff, where you can set the chargers to come on at a certain time. You can set the bus to heat up, which I thought that was a pretty cool add-on for this coming up year. Now, Cummins provides their powertrain, and they have a 194 kilowatt battery that is coming out. So it's bigger than the other ones. The other ones were up to 175. 194 kilowatt battery. And we didn't have a whole lot of information on that, but they're thinner, they last longer. So battery technology is definitely improving. It uses Cummins service and diagnostic software, just like Insight. I think I asked the question, and it's not Insight, but it's going to be really similar. It uses a Ford 6-phase motor. It has electro-hydraulic steering and chilled coolant that is only used for the batteries. So, and there was a lot more that he touched on. It was a really informative presentation. And like I said, that is recorded, and feel free to go on the channel and check that out. While we're talking about EV buses, does anybody have any news on the EV buses that they're running? Any updates or anything? I can tell you that here at Shen, we're back up to operating both of our chargers. They're coming on at 7 p.m. again, just like they were before. We had to have one of our portable chargers fixed, and that was right from Cummins. So they came and fixed that. It needed a new board. So we're back up in operation. We're charging all the buses at night, off-peak hours. because the midday charging that we used to have to do for the winter seems to be that we're okay. Buses are coming back with 60% charge, which is plenty for the rest of the day, the afternoon runs, and then they charge at night. So, and that's due to the heating element. Then we're no longer running the heat as much as we were over the winter. So that was a learning curve. We sort of expected that anyway, but now we have the facts. Those heaters use some power. So if nobody has anything to add to their own electric fleet, any information or anything, we will turn the presentation over to Chris Porter with Spheros.
All right.
Yeah,
Good morning, everyone. Hope everyone is doing well. Let me share my screen. Let me know if you can see it.
I can see it.
Perfect. All right. So as Daniel mentioned, spring is right around the corner, and we want to get these AC systems prepared for the summer ahead, right? And what's the one thing we should all be doing on these buses, every month? That's preventative maintenance, right? Keeping these systems alive. That's, it doesn't matter if it's for your automobile, for a bus, or for your house. Keeping the filters clean and things of that nature is the number one priority. And I know, Daniel, you mentioned things about checking pressures, and absolutely, that's the number one thing you should be checking, when it is preventative maintenance time, especially in spring. Check your pressures, put gauges on there. That's going to be the telltale sign if there is something wrong. That's going to be the indication, right? Just to kind of go over some formalities. So I am Chris Porter. I am the North America Service Manager for Spheros North America. I've been with the company for almost 11 years. Started out as an installer for 5 years at a lot of the OEMs located in Elkhart, Indiana. And then in 2019, I moved out to Phoenix, Arizona to become a West Coast field service tech. In 2021, I moved to Tampa, Florida to then become in the role I'm in now as service manager. And then July of last year, I decided to come back to the Midwest. So I'm right in Elkhart, Indiana, right on the Michigan state line. So being from the Midwest, I missed the seasons. Kind of hard to believe, but it's true. So also on here, our field service engineer, Chad Forgy, he's based out of this area. He will be the best line of defense when it comes to troubleshooting, or you need some wiring schematics, things of that nature. Chad will be a good contact. So there's his email on the screen and his contact, his work cell phone number. Our warranty gentleman, Sean Larson and Dakota King, both of those are great for starting a warranty claim, needing parts within their warranty duration. And then our sales rep for your area is Dakota Ellswick. And then just some of the agenda today. I know I have roughly an hour. So I'm going to skim through a lot of this stuff, but we'll talk about fundamentals, refrigeration theory, because that's really important right there. A lot of people do know refrigeration and basic AC, but I always like to emphasize the importance of really knowing the fundamentals, because if you don't know the fundamentals, it's hard for anyone to diagnose something, right? So we're going to dive into that a little bit and talk about system components, things from accumulators, filter dryers, to types of metering devices we utilize, condenser and evaporator, your radial and blower fans. What are your protections? High and low pressure switch, your freeze up thermostat switches, hoses and fittings, compressors, and then electrical components, along with putting most of our focus on preventative maintenance strategies, and then best equipment practices with our machines, charging and flushing procedures, and then some troubleshootings, and then we'll do some Q&A if there's time at the end. But of course, you guys feel free to speak up anytime I'm speaking on something and you want to challenge me, or you don't quite understand, you're scratching your head and you want me to explain it in a different way. I'm more than happy to do that as well. And for those of you who don't know, we used to be ACC climate control for many, many years. Up until 2016 is when Spheros, we call it 1.0, purchased ACC. And then 1 year later, Valio then purchased Spheros. Up until about July of last year is when we're back to the Spheros name. So we're separate from Valio thermal commercial vehicles now. And we're under the HIG Capital umbrella. That is our headquarters, Elkhart, Indiana, roughly 135,000 square foot, give or take 100 employees inside this building. As our offices, production, assembly lines, warehousing, and our R&D department. Over here on the right is our in-house calorimeter. We can pull, a full-size 62-foot long bus. Inside there, we can get that chamber minus 30 Fahrenheit below zero or positive 140 degrees up to 95% humidity. So, and also 3 install bays. So inside that chamber, a lot of our new products come out there. Different states have different mandates, different pull-on requirements that we have to meet. So we can kind of mimic wherever that bus and that system is going to be going throughout the country. So let's dive right into it, right? What is refrigeration, right? So are we cooling the bus or are we removing the heat, right? That's the question at hand. What are we exactly doing? Well, we are cooling by the removal of heat is exactly what we're doing. We're not cooling the air. We're actually removing the heat. We're capturing it within the evaporator, within the refrigerant itself. I always thought, before I was mentored and taught, that I thought of it as a bucket of ice with a fan sitting on it, just blowing cool air into the room. That's not the case. We're actually taking the hot air, drawing it through that evaporator coil. That refrigerant is capturing the heat and expelling it outside of your condenser unit. And then what's left of the air coming out is cold air. So the movement of heat from a place where it is not wanted to a place where it is unobjectionable. How do we measure that? In BTU, so British Thermal Unit. We're just transferring heat from one place where it's not wanted to a place outside, out in the atmosphere. Every AC system is comprised of these 4 components. Doesn't matter if it's for a bus, for your car, for your home AC, for your refrigerator. It's going to have these 4 macro components. And then you're going to have micro components that's going to change in between there. So number 1, you're going to have compressor. And on the Spheros type of systems, you're going to either have a swash plate style design compressor, or on the EVs, it's going to be a scroll type, very similar to the one on your house. Condensers, you're going to have aluminum parallel flow microchannel or a copper tube and fin. Metering devices, you're going to have a fixed metering device, right? So fixed orifice tube, or a TXV, thermostatic expansion valve. We are slowly transitioning away from the fixed orifice tubes. We started that about 2 years ago is when we started phasing that in, especially on the in-wall school buses. In preparation of if the EPA ever mandates us to switch over to the R1234YF. So right now, we're still utilizing R134A with the exception of our fully electric rooftop systems, and that utilizes 407C. And we have those on Bluebird buses, primarily in California and Arizona on the Bluebirds out there. I'd say we've been on those systems, those buses since 2016. We have over 500 out in California that's been out in the field that long. So it's a good, reliable, robust system. We really like it. And then evaporators, we mostly use copper because it does have a lower specific heat. All right, let's get into a basic orifice tube refrigeration circuit overview. So we have our compressor, our condenser, our evaporator, our accumulator, some pressure switches, and some charge ports. So let's pretend it's a nice hot day outside. We go inside that bus, we start the engine, and we turn on the AC, turn the fan speed on high. What type of refrigerant will we have coming out of our discharge port of our compressor? Are we going to have a liquid or a vapor? Right? Something to ponder on before I give you the answer. And we're going to have a high pressure gas coming out of that. A lot of people say we have a liquid. Well, it wouldn't be a liquid because these compressors are vapor compressors, not liquid. They're not designed to pump a liquid. And we don't want it to see a liquid because we have the chance of hydrolocking it and ruining some of the internal components. So we have a high pressure gas coming out of our discharge port of our compressor, going into, there's generally an inline filter on any one of our aluminum microchannel condensers. As the refrigerant travels through the condenser, here about the middle point, we're going to have what's called a saturated mixture. Okay, and what a saturated mixture is, you're going to have half liquid and half vapor present. That tells us that refrigerant is actually changing state. And how is that refrigerant changing state in that condenser? We have our condenser fans bolted to the condenser, and even though it's 95 degrees Fahrenheit outside, those condenser fans are drawing that air across that condenser coil, and it's rejecting the heat from the condenser. So that 95-degree air is, believe it or not, it's cooler than a temperature of that refrigerant. So then we're going to condense that vapor into a liquid form. So as the refrigerant leaves the condenser, we should now have a warm, high-pressure liquid. And the line coming out of our condenser going to our evaporator is always going to be your smallest line set within the refrigeration circuit. Most of ours, that's going to be your number 8 line. It'll have that black locator on it. The discharge port coming out of the compressor to the condenser, that'll be your number 10 hose with that yellow locator on it. So now we have a warm high pressure liquid traveling to our evaporator. Could be a rear end wall, a front end wall, midship. It's going to be traveling to our metering device. That metering device and that compressor is what divides your high pressure and low pressure side of the system. So when you're looking at your gauges, think about this. Okay, so everything on the high side is from the discharge port of the compressor all the way to the inlet of the evaporator, where that metering device is. That is on the red side of your gauges. Everything on the blue side, the low side, is anything exiting the evaporator going back to the compressor. So when you're trying to troubleshoot, think of where these problems and where they're indicated on your gauges, because it'll help you out. So that metering device, it's going to create a pressure drop, right? I like to think of an orifice tube as the analogy. What happens when you take a garden hose and you put your thumb over the top of it? It kind of sprays into a mist, right? And it's exactly what it's doing. It's creating that low pressure drop. That refrigerant is going to spread evenly into each one of the evaporator capillaries. And it's already going to start changing state right there from a liquid back to a vapor. So that refrigerant is then traveling back into the evaporator. And again, about the middle point, we're going to have another saturated mixture right here. Except this time, the outside air is not cooler than a temperature refrigerant. This time, it's hotter than a temperature of that refrigerant. So just like when we boil water, we apply heat, it turns back into a vapor form, right? That water does. That's exactly what is happening inside that evaporator. We're taking that cool refrigerant, we're applying heat, that BTU that's inside the coach, and then it's boiling that refrigerant back to a vapor state. We're not actually evaporating it, right? That's just a term we like to use, but it's actually boiling inside that evaporator. It's collecting that heat, and then what's left of that heat is cold air. And that's how we get our cooler temperatures coming out of the duct. Exiting the evaporator, then we should have what type of refrigerant should we have exiting that evaporator? Is it going to be a liquid or a vapor? It should be a cool low pressure gas, right? If we don't have a cool low pressure gas, if we still have a lot of excess liquid, then we're going to have trouble with that compressor, right? Maybe that evaporator coil is dirty. Maybe nobody's changed the filter in 6 months. Maybe nobody's cleaned that coil in 6 months. And if that evaporator is obstructed with something, that evaporator can't do its job. And its job is to collect and absorb heat, right? So then coming out of the evap, low pressure gas, and on an orifice tube system, you're always going to have an accumulator versus a filter dryer in line. And that accumulator is going to be placed inside the largest hose on the system, which is your suction line. Most of our systems, it's going to be number 12. It'll be that green locator. So with a fixed orifice tube, we know that metering device, it can't modulate back and forth. It cannot control superheat. So what we do is any excess liquid, let's say 98% of the liquid going into the evap does get boiled off, but there's still 1 to 2% liquid that doesn't get boiled off because orifice tube can't modulate. So any excess liquid is going to fall into the bottom of that accumulator, and then it's going to finish boiling inside there. So, heat, and that typically sits under the bus, near B pillar, and any excess heat from the road or just heat soak from under the bus is going to help boil that refrigerant before returning back to the compressor. And then the cycle continues. So accumulator is used for an orifice tube application, like I mentioned. And what does it do? It helps prevent compressor flooding, boils off any excess liquid refrigerant before returning back to the compressor. It helps store refrigerant when the system is shut off, because a lot of our systems are microchannel condensers. They're smaller, they are more efficient, but they don't store a lot of refrigerant. Helps store oil, lubricate the compressor, cool the compressor, and then always remember, whenever the system is exposed to atmospheric pressure, make it a common practice to replace that filter dryer or accumulator, because inside here, I cut one open for an example, is what's called a desiccant bag. And that desiccant bag is designed to absorb moisture. That's the same type of material that comes in a bag of beef jerky, that little white packet, or a new box of shoes, things like that. It's designed to collect moisture. Well, when you remove the caps or you take a fitting off here and then you expose it to atmosphere, you're exposing it to the moisture around you. And then a lot of times the vacuum pump will not capture all the moisture out of those desiccant balls. So say you got a bus that pulls in and it's got a loose fitting on here, go ahead, recover the refrigerant if there's any in there, and then change that O-ring if the O-ring's torn too, and then make it common practice just to go ahead and replace that. Be proactive. Especially when these are under warranty, our guys will have no problem sending you one. So, and at the bottom of the accumulator is a pickup tube. If for whatever reason this pickup tube starts to get clogged with any kind of debris that's in the line set coming from the evaporator, then you're going to starve that compressor of oil. So keep that in mind. And then here's a complete overview, outlining the service ports and the pressure switches. So is there any questions on this circuit overview for an orifice tube before I move on? No? All right. Let's continue. Now let's talk about a TXV, right? Refrigeration circuit overview. So same principles. Everything AC functions the same. High pressure gas going into the condenser. We condense it into a liquid. Except, wait a minute, now we have a filter dryer in the liquid line versus your suction line, right? Because now that we have a TXV, we can control the superheat, right? Way greater. I like to think of an orifice tube as a carburetor system versus a TXV as fuel injection, right? Now we can really modulate and control it. So we're going to have practically no excess liquid exiting the evaporator on a fully functioning and operating AC system. So that's the major difference between the TXV and an orifice tube. Is one utilizes a filter dryer, one utilizes an accumulator, And then also on TXVs, we do utilize a freeze up thermostat switch, which is a temperature probe that gets placed directly into the evaporator coil. And once that evaporator reaches a certain temperature, let's say 36 degrees, it'll kill power going to the compressor clutch to protect it. Because if this coil ever freezes, turns into a block of ice, guess what? We can't get airflow across it. We can't absorb the heat. So therefore, we're going to have excess liquid traveling back to the compressor. And they are located, like I said, from the condenser, in between the condenser and the evaporator, versus the accumulator is at the evaporator to the compressor. Just like the accumulator, always make it a common practice to replace it whenever it's exposed to atmospheric pressure. And on the filter dryers, they are directional. They typically have an arrow showing you which way they should be installed. And they do have a sight glass with a moisture indicator that'll outline if there's any moisture inside the system, or if it's not charged properly, or if we have something wrong. Theoretically, this sight glass should be free and clear. It should be flowing nice and clear, all liquid refrigerant. If you see any vapor bubbles in there, then we have something wrong with the system. Maybe it's not charged properly, undercharged, overcharged. Maybe we have non-condensables, right? That's a refrigeration term inside that system. Maybe when technicians hooked up a set of gauges to the bus, when they're doing their preventative maintenance, they didn't purge the air out of their gauges, right? A lot of technicians have a loose set of gauges hanging up on the wall. They keep their gauges zeroed out. They don't keep them preloaded with refrigerant. And what happens is technician takes those gauges, installs them on a functioning bus, threads down his couplers. Now he's got to fill that line set, right? So each hose maybe holds 1/8 to 1/4 of a pound on his high and low gauges. And what happens is that's PSI G, so PSI gauge, right? And it's not PSI atmospheric pressure. Well, all of us at sea level are sitting at 14.7 pressure, right? PSI G or PSI A. So we just introduced air to that system, which we don't want to do. So a good common practice, before you hook those gauges up, fill it up with refrigerant first, purge all the air out of it, then hook it up. Because if you don't do that, we also, when you take your gauges off that bus, does that refrigerant stay in your gauges, or does that refrigerant go back into the bus? Well, it's going to stay inside your gauges. So now we just shorted the circuit of that system, maybe 1/8 to 1/4 pound of refrigerant. Well, if you do that, 4 or 5 times over a couple seasons, you're wondering, wow, this bus doesn't have a leak anywhere, but where's the refrigerant going? Well, it keeps going in your technician's line sets. So TXV, just an overview for people who don't quite know what a TXV, thermostatic convection valve, is. It is a meter device. TXV, what's it do? It meters the amount of refrigerant to match the evaporator load and maintain a constant superheat of refrigerant gas, leaving the evap, right? And like I mentioned before, that is what divides your high and your low side of the system. So this is a block valve style. I'd say 80% of our systems utilize a block valve. The rest of them are going to be a right angle with an external sensing bulb. So most of your automobiles have a block valve style where everything is built internally. And on the top here, this red line, there's a power head filled with a gas on top of that diaphragm. And under the diaphragm is an expandable bimetal strip. As the temperature of the vapor leaving the evaporator increases, the bimetal strip expands, pushing off of its pin, off of its seat, allowing refrigerant to flood the evap. So over here is the condenser. On my left is the evaporator. So going into the evaporator from the condenser, we're going to have a high pressure, high temperature, subcooled liquid. It's then going to create that pressure drop. It's going to start to change that refrigerant gas. It's going to go from a liquid to a vapor right there. It's already changing state. It's going to turn it to a low pressure, low temperature, saturated mixture going to the evaporator. It's going to travel through the evaporator, absorb the heat inside the coach, and then coming out, we're going to have a low pressure, low temperature, superheated vapor going into the block valve, and then same thing returning back to the compressor. Some troubleshooting on expansion valves. What are some symptoms of a bad TXV, right? Frost on the evaporator or coming through the vents, low suction or head pressure, high evaporator and compressor superheat, short cycling, low pressure control. What causes a TXV to freeze? Excessive moisture inside that system or a saturated dryer, right? If you guys are replacing, let's say you don't have time to, or you don't have parts availability when you are doing a repair on a bus and you can't change that filter dryer, try and do the best you can to leave that system on a vacuum until you reach that 500 micron goal, right? There's no time bearing on how long it takes to get to that 500 microns. But excess moisture, that right there is the #1 cause for failed compressors. And can a dirty or clogged TXV be cleaned? Block type, no. Best practice is just to replace. Right angle, maybe check to see if there's a valve on an inlet screen, see if it's not clogged or contaminated. But again, it's best just to replace it. Also, not noted on here is these are typically covered with a cork or butyl tape, the black rubber tar. Ensure that it's always covered, because if it's not covered, then that TXV is sensing external ambient air versus what it's designed to do is read the pressure and temperature of the refrigerant. It's not supposed to dictate what the inside of the coach is supposed to be. So you get some fluctuations on that. And then whether this diaphragm is on the top or the bottom, less dependent on the evaporator coil design. On top, this one right here, your liquid line is going in, it's going to feed the capillaries. And then this will be your exit. And then some more troubleshootings. Symptoms, suction pressure is high and superheat has a low reading. What is the possible cause? Maybe we have a defective compressor, incorrect TXV, maybe the wrong tonnage. Maybe technician installed a 1.5 ton versus a 2.5 ton TXV. Poor sensing bulb contact with a suction line. Maybe it's overcharged. What if we have suction low pressure and superheating reading high? Maybe it's a low refrigerant charge. Again, maybe it's the incorrect TXV. Maybe there's no charge in this power head element. That power head is filled with a certain type of refrigerant itself. And whenever that refrigerant, for whatever reason, let's say a solder breaks or a seal lets go, then that TXV is going to stay slammed shut. That's a dead indicator. When you go and put a set of gauges on there, you turn the AC on and your low side immediately falls into a vacuum. That's how you know the TXV is not opening. Maybe we have vapor in the liquid line or a plug receiver or a filter dryer. And then on here, suction pressure is low and superheating reading is high. Maybe we have a clogged filter dryer or a clogged return air filter or coil. Maybe the coil is iced over. Maybe we have excess oil in the evaporator. There's too much oil in the system. I know with our systems, we inject on TM16 and TM21 compressors, we put 1.75 ounces of oil per pound of refrigerant. And then our larger compressors, TM31, 43, 55, and 65, we go off of the sight glass on the side of the compressor, whether we need to add or subtract. Some of our evap assembly components on free blow systems, which is a hanging evaporator. Our orifice tubes, the colors just dictate the size of the orifice itself, which is right where my cursor is. That is the orifice itself. So refrigerant travels in Any debris will get caught on the screen and it'll come out and then it'll mystify, it'll spray. So looking at this orifice tube, that's the correct orientation. It'll spray into each individual capillary as so. Our orifice tubes, they're not thread-in. They are a push-in style with a double O-ring. Do recommend using mineral oil on those as a lubricant. And ensure you don't place those orifice tubes in backwards. I have seen a few cases to where these were installed backwards, and the system will work. It's just not optimal. And typically, the orifice tube will not come out one piece. So then you've really damaged that coil. And then our blower motors, our resistor is directly on the blower itself, and then just the block valve TXV. Some condenser assembly parts. We have our small brush fans. On the EV stuff, everything is brushless, but anything not is going to be a brush fan. Anytime we're using a parallel flow microchannel aluminum condenser coil, we're going to have an inline screen filter. There's going to be a screen on the inlet to try and capture any debris before entering that condenser coil. So there's a reason why they call it microchannel, right? And you can see we cut one open right here as a cutaway. Those are very, very fine channels that refrigerant is traveling through. Again, good practice. Let's say you have a bus that comes in, you put your gauges on it, the clutch is engaged, you're blowing hot air out of the vents, and your gauges are trailing each other. We know we have an equalized compressor. It's not pumping anymore. You open up the system, and there's this black, silver, metallic flakes everywhere throughout the system. For us, it's good practice just to replace the condenser. Don't even try and flush it. Me and my service team, we've personally experienced flushing about 10 gallons of a solvent through those condensers, front flushing, back flushing. We're still getting contaminants out of it. So by the time you spend the money, the time on the solvents and the mess, just be proactive. Try not to get a call back. Replace the condenser. It's going to be cheaper in the long run. Now, if this was a copper tube and fin, sure, you can flush that out. It has larger channels just like your evaporator does. Hoses and fittings. We use Galaxy Burgaflex hose and Atco fittings. So the number 6 locator, and we call it clips locators. That's going to be your liquid line, maybe on a smaller dash system, right? That's not going to be on your front or rear end wall. That's typically going to be on your really smaller BTU systems. Number 8, that's going to be your liquid line. That's your line from the condenser to the evaporator. Number 10, yellow locator. That is coming from the discharge port of the compressor going to your condenser. And then your number 12 and 16 is your suction lines. Those are the lines exiting the evaporator going to your compressor. Or if it's an orifice tube, it's going to go to your accumulator first, then your compressor. And then make sure your suction lines and fittings are insulated because they will condensate. And we want to maintain that temperature of that refrigerant exiting the evaporator. So think about your house outside. You go outside your condenser unit, you see that foam, looks like a pool noodle wrapped around that line, right? Well, it's not just there to protect the line from somebody going in there with a weed whacker and hitting it accidentally. It's actually designed because, and who cares if it sweats outside, it's typically falling in grass or rocks. But we want to maintain the temperature of that refrigerant. Because what did we just do? What did we just do? We just raised the temperature of the refrigerant in the evaporator. We boiled it to a vapor, right? Because we want it to be in a vapor state returning back to the compressor. What we don't want to do is cool that refrigerant. Because when we cool it, it's going to turn back to a liquid. And that's the condenser's job. So we want to have that suction line insulated to maintain that temperature. That way we don't try and hydrolock that compressor. So TM21 compressor, I'd say that's probably one of our most popular compressors we utilize. And even though, so this is a Valio compressor, even though we were Valio prior to this, Valio compressors was a separate entity. So that was Valeo compressors. We were Valeo TCV, thermal commercial vehicles. We are still separate from them, but we're still utilizing their compressors. That can be used on 12 or 24 volt applications. How do you tell the difference between a TM16 and a TM21? Well, it's pretty obvious. The clutch hub itself is slightly larger, and there's 2 wires coming off the compressor versus 1. Any compressor that has just the power wire coming off, know that it's internally grounded. So you always want these contact points to be clean when it's up against the engine or an auxiliary bracket kit to ensure you have a good ground. Pressure relief valve on the back, that'll relieve pressure around 450 PSI. And that's kind of a safe fail if your pressure switches ever stick, right? Let's say it's hot outside. Driver says, hey, AC is working intermittently, but I'm going to keep on going because we don't have another bus we could utilize. Eventually, let's say we have a condenser fan that's out and we have head pressure bouncing off the high pressure switch. Eventually, that pressure switch, after thousands of repeated times, it's going to stick. Our next safety is to relieve pressure at the back of the compressor before imploding in the evaporator with the students. So anytime that pressure does relief, it'll look like fire suppression going off under the hood, makes a giant mess. There'll be PAG oil everywhere. They do typically reseal on their own, but it's good practice to replace the compressor because these compressors are designed to operate around 300 PSI max. So once we do exceed that 450, we have the risk of bending one of the reed valves inside that compressor. So be proactive. You could gamble and say, hey, we don't have any more compressors. Bus has to get back on the road. We don't have any down buses. Let's do this in the meantime. But it's always our best practice just to replace the compressor. And all of our compressors, that is a swash plate style design, does utilize PAG 46 oil that already has dye injected into it. So PAG just means polyalkylene glycol, and then 46 is the viscosity of it. And what is the most common reason why compressors fail? Well, flooding, right? Excess liquid, loss of lubrication, clogged metering device, clogged accumulator filter dryer, contamination, non-condensables, meaning moisture, overheating, right? Too high of compression ratio. And I'm not talking about a race car that's 14.5 to 1 compression. Compression ratio in refrigeration is the greater the distance between your high pressure and your low pressure, the farther those are far apart, the hotter the refrigerant returning back to the compressor is. So that compressor is going to receive most of its heat when you first turn on the system. The longer it runs, the cooler that refrigerant is going to get returning back to the compressor. You should be able to put your hand gently on the compressor and not scald your hand. If you ever have a bus that's come in and all the serial tags are burnt away, then you know it's been overheated. There's something wrong with the system. Check for loose grounds, connections, right? Make sure that ground wire is secured properly. We always recommend a ground stud on an alternator, negative terminal on a battery, or even like an OEM location on the firewall. Those are 3 solid secure points. You could put it directly through the mounting point right here. Just ensure that engine is grounded good. You don't have any excess powder coat going in that bracket. And then another reason why compressors fail is maybe it's not seeing 12 volts, right? So what happens when this compressor doesn't see a constant 12 volts? Well, that clutch, it's going to be slipping all the time, right? Think about an inexperienced stick shift driver always slipping the clutch. That's what's going to happen if it's only seeing 10.8 volts. Most of our systems, if that 14 gauge wire coming off of our relay board is longer than 25 foot, we'll add an auxiliary compressor relay to ramp that voltage back up. And then I'll show you a video of the internal workings of a compressor. So here's your swash plate, your crankshaft. These are your pistons. These are your reed valves, very similar to a two-stroke. So you get your cool low pressure coming in, you compress it. What happens when you compress an air or a liquid? It generates heat, and that's what makes your high pressure. So low pressure coming in, high pressure going out. I'll play that again for you. Here's an example of a compressor that was only seeing 10.8 volts. All of the rubber dampeners are gone from this clutch hub itself. This one was seeing 10.8 volts due to a bad ground, right? It looks like a technician they rerouted the ground wire to the chassis frame itself and did not clean off the undercoat nor use a star washer. So we were measuring 10.8 volts. Once they changed out the compressor, we went on site, we measured again, 10.8, we cleaned up that ground, guess what, 12.5 volts. And here is a piston out of an equalized compressor. And this is when we're flushing the system, that's kind of the debris when we get out of that system. Most of our systems, if we have an internally failed compressor, we're going to go through about 8 to 10 gallons of solvent. I know a lot of shops maybe use a couple of the small cans. Realistically, that's not enough to fully clean out a system. To do it properly, you're going to use upwards to close to 10 gallons of solvent. And then that solvent, you can reuse it more than once or twice to get all the gunk off the walls, off the interior barrier of the hoses first. And then once it starts to get really contaminated, you can flush it with clean solvent. And here's a reed valve body. This one has a broken reed valve, as you can see. I got a video clip of what it'll look like, what your gauges will display once that happens. On every compression stroke, it's losing that compressor. It's falling out. So if you ever see one of your gauges fluttering like that, know one of these reed valves could be bent or broken. So this one, somebody actually charged it on the low side liquid. And when they first turned on the system, it hydrolocked and it broke the valve right away. So this was during a repair. Relay board with our digital controller. You might have a digital controller. You might have a standard rotary analog style, but the relay board itself is standard. We have a 5 relay as a standard, so low, medium, and high for your blowers, your condenser relay, compressor relay, and then we have a holster holstering that power wire onto the power stud. So any kind of vibration, bumps in the road, we can prevent this connection from coming loose. And then the connectors are Wago connectors. So these simply flip up. You can insert the wire directly that way. Makes it easy to, if you ever have to replace the board, it makes it more simplistic. And they do have LED indicators to try and tell the technician what's going on with the system. Is it functioning properly? Do we have a background? Do we not have power? Things of that nature. And then our switch harness up here. So more preventative maintenance, debris on a skirt mounted condenser, or if you have a roof mounted condenser, same thing, right? Go ahead and take your garden hose and hose this off. If you have a condenser brush comb, go ahead and use that to help straighten some of the fins out. This particular unit here was seeing about 30 PSI higher on the high pressure than what it should have seen. because we couldn't reject the heat completely like we should, because we had over, roughly a quarter of the condenser plugged with dirt and debris and mud. So something to do on your PM schedule. Again, just do a simple visual walk by. Does it look clean? Even if it looks clean, I guarantee you take a garden hose to it, you're going to see a bunch of dirt and muck falling off of it. Same thing with your house condenser outside. You go outside, you take a garden hose to the top, you're going to see dirt start to melt down the side. And then dirty return air filters. Make sure, this is the #1 compressor killer right here, in our opinion. It's just lack of preventative maintenance. Making sure those filters are clean. Same thing with your house. If you have a bunch of dogs, you should make that a priority to change it at least once a month or as needed. Just keep an eye on it. Pay attention to it. If you want to prolong the life of the AC system on this bus, make sure those filters are clean. Most of the filters you can take to shop air and blow them out. In severe cases, wash them with soap and water, let them dry, reinstall them. Here's an image of an in-wall on a school bus, and that is the evaporator coil itself. There was a filter on there, and we got called down to the school district in South Florida. They said, "Hey, we're on our 3rd compressor this summer, and you guys are sending us junk compressors. Come down. We're tired of working on it. Take a look at it." So I go on site and I asked for their service records, and yeah, it says they checked all the boxes. They've been cleaning the filter, so on and so forth. And they did. They replaced the filter probably just before I got on site. I took the filter out, and this was what was exposed, right? So they never replaced the filter ever since the bus has been in service, and they never bothered cleaning the coil. South Florida is very, very humid, right? So when these things condensate out of the drain lines, it is like a faucet just running. And this right here was causing the compressors to slowly slug and fail, lose compression, just because of lack of maintenance. Another example, dirty return air filter. Again, completely unacceptable, right? This is either a school district just not having the knowledge or the know-how on things like this. I know a lot of drivers, they might see if the belt's on the engine, they might check the oil, they have some of their pre-trip routines. Well, something else they can do is just get their flashlight out and look at the filters and see if they need cleaned or not. More preventative maintenance. Make sure the kazoo valves are located on the bottom of the drain lines. They do serve a purpose, right? If those kazoo valves, rubber flap, duckbill, different terms for them, what that does is that actually creates pressure inside of that evaporator coil, right? We want that, it helps create back pressure for the blowers can push water out of the drain lines versus trying to get captured inside the blower motors and blow out on the students. Also, it keeps from any kind of bugs or mud or anything plugging this drain line. Because what happens when this drain line gets filled, starts to fill up with water, drain pan fills up with water, the coil then is going to start to turn into a block of ice. Then on an orifice tube system, doesn't have that freeze up protection. Then it's going to start to, it can't convert that liquid refrigerant back to a vapor. You're going to slowly slug the compressor and take it out because a kazoo valve is missing. Something else to keep an eye on is leaking Schrader valves. And this is something that you won't find when you do have your AC machine hooked up to it. It's going to say, hey, it's leak free, pass leak test, because both couplers are hooked up. But when you remove your couplers and you put the bus back into service, that's when it's going to slowly start to leak because the Schrader cores in here are not tight or it's just got a bad seal. And then nitrogen, that's something everyone should have at their facilities. That's probably my favorite tool to have when I'm trying to diagnose a leak, right? So recover the refrigerant. You know there's a leak somewhere. Don't know where it is. Recover the refrigerant. Go ahead and inject on the high side of that system. with 250, 275 PSI of nitrogen. That's going to put that pressure throughout the entire system. You can use something like Cali Blue or Big Blue, just something thicker than like a Dawn dish soap. It's going to draw a large bubble and show you where that leak is. Very similar to you looking for a leak like a nail in a tire. It's going to draw that bubble. And then a leak detector sniffer, probably my least favorite tool to have in my belt. It's nice to have maybe in an area that's very difficult to get to and you think the leak is back there, but not the most reliable. And then nitrogen, it's good to use for run 1 to 2 PSI when you are brazing to keep copper piping from oxidizing. And then they do make an evaporator coil cleaner. You can put that in a spray bottle. Once you clean the filters, maybe once every 6 months, go ahead and spray that on your evaporator and condenser coils. This particular brand is self-rinsing and it's biodegradable. So you can let it run off the drain lines. And you don't have to worry about it. Just run the AC. Here's an example of what our flushing equipment looks like. We use a 1-gallon tank that we do pressurize with nitrogen versus shop air. Because what's at the bottom of our air compressors in our shops? Water, right? We're trying to dehydrate a system as fast as possible. So it's okay to use shop air initially for the first couple gallons, but once it starts to get clean, go ahead and push it with nitrogen. And then just an image of our AC equipment. This is our Revo E Global on a Bluebird fully electric system. That's the one that utilizes 407C refrigerant. And this type of setup is just more friendly for the mobile guys, very similar to a commercial or residential. Because let's say Robinair or Snap-on machines, we tend to lose calibration on the scales and have bad electrical connections when traveling down the road. And this type of setup, we have way more control. You know, on the top, we have our micron gauge, our vacuum pump, weight scale gauges. And then like in this image, we have our vacuum pump over here again, a digital manifold gauge set. The only thing not shown is a recovery machine and an oil separator. And then one more thing I want to touch on, because I know time's running up, is I like to see everyone using a micron gauge. And what is a micron gauge or a micrometer? And why is it important? Let me tell you why. Most people think once they achieve 29.13, in that 29 inches of vacuum, that they have a good vacuum, there's no leaks, the system's good to charge. Well, that's kind of false, because at 29.13 inches of mercury, water is going to be boiling at 72 degrees at sea level. That gauge is going to read 20,000 microns, a digital gauge. A standard for refrigeration for automobile, for commercial, residential is 500 microns. And microns, in layman's terms, is moisture content inside the system. So 29.90 is an optimal vacuum, 500 microns. Water is then going to be boiling at -12 below zero. So what does that tell us the vacuum pump is actually doing to the system? We're not pulling air out of the system. We're actually changing the boiling point of water. So if I had a vacuum pump in front of me with a clear tube with water in it, and I turn that pump on with a micron gauge, eventually you would start to see the water inside that tube start to boil away. So if you can achieve 500 microns, 29.90 inches of mercury, we know we have practically no moisture inside that system, and that we're going to have a nice long life of that system as long as we keep doing proper preventative maintenance. And for the people who have machines, you can simply tie one of these in on your low side. So take your low side coupler from your machine, tee that in, and then have another charge hose going to the bus. And once you achieve that, anything under 500 microns, shut the machine off. If that doesn't rise above 1,000 microns within 10 minutes, you're good to charge. And then at the end, this is our standard preventative maintenance guideline on what to do for daily pre-trip, weekly, monthly, quarterly, semi-annually, and an annual inspection. with the system on and off. The biggest thing I can focus on for you guys is just make sure that those filters are clean. Other than that, you guys have any questions for me? I know that was kind of a lot in that short amount of time, but if you guys have any questions, feel free. We can take this offline or however you guys want. But thank you.
All right. Does anybody have any questions? Hey, quick question is what do you use to flush the system? Like if there was debris in the system, what would you use?
Yeah, so when we first bought our flush kits for our team, it came with its own solvent. And what I did was I took that solvent, I went outside, poured it on the concrete. Well, guess what? I came back in 10 minutes, it was still there, right? That means it has some kind of oil in it. I don't want that in my system. So denatured alcohol or a non-chlorinated brake clean are the two that we recommend.
Okay.
Hi, Chris. I have more of a comment. A lot of our vans have both the orifice tube and the TXV valve. Do you see that a lot? And it does make it hard to diagnose sometimes. A lot of times we'll find metal chips in one, so we'll have to change both.
Yeah, realistically, you want the same metering device. If you have an OEM and an auxiliary, you want them to be the same.
Yeah, that's not the case in just about all the Type A chassis we have. They all have a TXV valve in the split system in the cab, and then the dash air will have the orifice tube.
Yeah, it makes it harder for that TXV to fully do its job because it's constantly modulating, trying to compensate for that lack of on the orifice tube.
I have read that not to use the PAG oil for lubricating fittings and O-rings. Is that correct?
Correct. Yeah. So we always recommend mineral oil because PAG oil, it's very hydroscopic, right? It's designed to collect moisture and absorb moisture. So what's that going to do to O-rings? It's going to try and dry them out. Just like PAG oil. PAG oil, that's something you guys should be changing. We change them out in the field maybe every 2 or 3 buses, our vacuum pump oil. So same practice because, again, it's designed to collect moisture. And if people aren't changing their vacuum pump oil every 6 months or once in a year, if you're using a true micron gauge, that micron gauge is going to indicate that. You'll never achieve 500 microns. You might hover around that 2,000 to 3,000 range, but you'll never achieve that 500 goal.
Sorry to ask questions.
You're fine.
What do you see? We haven't had a lot of experience with the YF yet in our school buses, our Type A and Type C chassis. Is there any operating differences between the YF and the R134, like pressure-wise, time to vacuum? Do you see any differences?
So operating pressures would be the main difference, right? I don't have any personal experience with them. We don't have them on our systems yet, but other than the vacuum time, that's all going to stay the same. So what's going to change is operating pressures, knowing what they should be, going off of a pressure temperature chart designated for whatever type of refrigerant you're using. You know, every refrigerant has their own table, and that's typically stamped on that 30-pound jug of refrigerant you purchase, or you can Google search it. And then your safeties, those prescribed pressure ratings will change. You know, what's the cutoff on the high and what's the cutoff on the low.
Thank you for your time. Very good presentation.
Thank you.
Okay. Does anybody have any other questions for Chris? Not seeing any. If you have any, as normal, let me know, and or you can contact Chris directly. And but I'm sure if you have a question, everybody else is going to want to know also. So we'll make sure that your questions are answered. Our next presentation will be held on April 16th. It will be Cody Shamrock. We'll be talking about the international electric buses and the changes that they're making. Then we have May is Thomas. June is our DOT roundtable. And in July is the summer seminar. So, and that's coming right up. I know we're getting a lot of the application forms filled out. It should be, it's on its way. Thursday, July 17th will be the event, and July 16th will be the setup. If anybody has any more topics that they would like covered for this upcoming year, we've got to put our schedule together. So please let me know, and we can make sure that we get a presentation on that. Also, we could use a little bit of help. We're just looking for a vice president and a treasurer. So if you guys would like to help out, it's not a lot of work. Try it out. And yeah, it would be appreciated. Does anybody have anything else to add to today's meeting?
Yeah, are you, is everybody up to speed on the DOT's new accident/incident notification requirements? I received information from one of my neighbors. I never received anything from DOT directly, and the inspector seemed to be quite confused as to what I'm talking about. Are you aware of that? And is all the other carriers aware of that?
I did receive a little bit from that, and they were going to present on this during their roundtable. But pretty much what they were telling me is if anything has to be towed, you have to report it. Or if anything takes the bus out of service, you have to report it. So if a bus backs into another bus in the parking lot and the corner of the bus breaks the window in the door, that bus would be out of service. You can't use it. You have to report that. That's what our inspector told us. And other than that, I think it's pretty much the same, but you do have to report it. Now, it doesn't have to be re-inspected. It's, you're just going to change that piece of glass and put the bus back in service. But because the bus was out of service, had an out of service defect, then you have to report it.
Okay, just wanted to make sure everybody was aware of that new document that's out now.
And if the bus has to be towed, your bus was in an accident, it's towed back to the shop, you fix it, that also has to be reported because it was towed.
Okay. The way I read it is any mechanical failure that causes the bus to not complete the route has to be reported. The bus has to be held out of service till DOT makes a determination.
Yeah, and our inspector told us to give him a call and let them make the call. So call them up. I mean, we had one of our EVs stop in a parking lot. It wouldn't work. It ended up starting to work, but we took we took a sub bus, replaced it, and another bus went on that run. We went out to the bus, cleared the codes, and was able to drive it back. Now, because it couldn't finish its run, that had to be reported.
All right. I just want to make sure everybody's starting to hear more information on this.
Yeah, and we'll get it right from them, because the inspectors they're saying that for now, make sure you call them. So keep your inspector in the loop. And I will work to get them a statement, just an explanation on it. All right. Does anybody have anything else to add to today's meeting? Not seeing any. I'm going to go ahead and close the meeting, and we will see you guys next month. Thank you, Chris, for your presentation. It was very informative.
Thank you for having me.